Hello, welcome to the video. In this lesson, we're going to be looking at section 8.4, where we're going to use proportionality theorems. So there are different theorems that we're going to be given with respect to parallel lines. And these parallel lines, or angle bisectors, and they're going to help us write proportions to solve any unknown values um, to side lengths of triangles. So looking at the first one, what we have here is a triangle proportionality theorem. So if we have two line segments that are parallel in a triangle, so in this case, TU is parallel to QS, then what the conclusion we can make is that this side measurement is going to be, the ratio of this side measurement is going to be proportional to this one over this one. That's what they're saying. And then the converse of that is that if those two ratios are proportional, then the two sides are parallel. So using one of those two theorems, they're saying that QS and UT are parallel. So with that information and the side measurements that are given to us, they want us to find our Q, which is right here. So since it's parallel, I'm just going to call this X. So that means that X over 9 is going to be proportional to 4 over 6. So that's what the theorem told us. So we can do cross product. So this is going to be 6x is equal to 36, divide everything by 6, x equals 6. So your value would be 6, knowing that QS and UT are parallel. All right, same idea. Now they want us to find YZ, so this is going to be our new value of x. So now plugging this in, it's going to be 44 over 35 is going to be proportional to 36 over x. Doing the cross products, I get 44x is equal to 36 times 35, which is 1260. Dividing everything by 44, x is going to be about 28.64. About. All right, so here it says on the shoe rack shown, BA is 33. So I'm just going to write that in. BC is 27. All right, so CB 27, let's write that in. CD is 44. And DE is 25. So they're explaining why the shelf is not parallel to the floor. So this is the shelf right here. They want to explain why the shelf is not parallel. So basically we can say that it's not parallel. So they're trying to show that BD is not parallel to AE, and you can prove that by using, so you can say like, oh, 27 over 33, they want to make sure that it's not equal to 44 over 25. So if I multiply, let's say if I multiply 33 and 44, 33 times 44 is what, 1452. 27 times 25 is 675. All right, 675 does not equal 1452. So because it's not proportional, we know that BD is not parallel to AE. Here we have a theorem where you have three parallel lines. And so the three parallel lines here are as shown. And they say that if three parallel lines intersect two transversals, they divide the transversals proportionally. So what they're saying here is UW, which is right here, divided by UY, which is on the same line, is proportional to VX over XZ. All right, so they're just part of the same line, but one writes in the numerator, one writes in the denominator. Okay, so here it says angles 1, 2, and 3 are all congruent. So we don't know what that measurement is, but we just know that they're congruent. GF, which is right here, is 120. DE, which is, oh, they already have the measurement, sorry. DE is 150. CD is 300. They want us to find HF. HF is right here. So in order to do that, you have to find HG. So we'll call that X. So we know that since they're the same measurements, these are parallel. So what that means is I can take 150 over 300, and that is going to be proportional to 120 over x. So with that, I can do the cross products here. So that's 150x is equal to, let's see here, 300 times it by 120, which gets you, what, 36,000? Divide that by 150. X is 240. All right, so this right here is 240. But the question they asked was, what was this value here? So it's essentially HF is going to be 240 plus 120, which gets us to a value of 360 yards. And now for this one, we have an angle bisector theorem. So if you have an angle that bisects an angle, so remember that when you bisect it, whatever this angle is the same as that angle. And if that is to be true in a triangle, they're saying that whatever this measurement is, AD, over whatever the other measurement is, DB, is going to be proportional to CA over CB. So think about it like this. So the one ratio is the line segments that get the from the bisection. And then on the other side, so I see, oh, I see AD is right here. It shares with AC. So they kind of, there's kind of a correlation there as well. So try to keep that in mind when you are solving these. All right, so here it says that QPR is congruent to RPS, so they bisect. They want you to use the given side lengths to find the length of RS, so this value here, which is X. So looking at this using the theorem here, it's going to be QR over RS is going to be proportional to QP over PS. All right. Now, QR, they don't give us a measurement, but they tell us that QS is 15. So essentially, QR is going to be 15 minus X. divided by RS, which is X, is going to be equal to QP, which is 7, and PS, which is 13. So here I do cross product, so I get 7 times X, which is 7X. This turns into 13 times 15, which is 195, and then 13 times negative X, which is minus 13X. So I just distributed 13. Here I'm going to add 13X, so now I get 20X is equal to 195. 195 divided by 20 is about 9.75. So X is 9.75. So I just want to make sure, yep, that's RS, and that's what we're looking for. Okay. These two are relatively similar to the other one. I'll do number 4. So they want you to find JM, which is right here. So I'm going to call that X. Since I have all 90 degrees here, I can say that all 3 of these lines are parallel. So knowing that those 3 lines are parallel, how to set up this proportion is going to be 16 over X is going to be proportional to 15 over 18. So if I do cross products here, I get what? 15x is equal to 16 times 18, which is 288. Divide that by 15, I get 19.2. And, oh, that's it. And then that is, or, oh, here we go. Sorry. Let's do one more. Let's do one more with bisection. So let's do number 6. I'm trying to find y. We have our angle bisection here. So to set up this proportion, it's going to be 4 over 4, which is going to be equal to proportion to 4 times by the square root of 2. Well, over y. So here's the thing. Since this ends up being 1, this has to be the same thing. So y is going to be 4 times by the square root of 2 as well. And that is being able to look at proportionality theorems. Hope this helps. Till next time.